Okay, can you guys hear this? Oh, okay, yeah, there we go. My loop back didn't work. Sorry, guys. Basically, what I was saying is that, this whole article is basically just a fluffed up version of, oh shit, social media bad. That's it. I don't think it's just saying social media bad. That's it. That's literally all this entire article. So, I don't know. I really cannot say. Come on, man. Blah blah blah. This is just a holy shit. What a waste of megabytes just to write all this. It must be a slow news day. All right, whatever. We're moving on. Containers are CH root with a marketing budget. A container is like a VM, but it shares the kernel, so it's more lightweight. It doesn't simulate the hardware. It's just user space of the operating system. All right, interesting. Yeah, let's see. Let's see what the hell this is up about. What this is about. Calling them lightweight VMs because they share a kernel with a host. What is sharing the kernel with the namespace and specific kernel visibility? But for me, containers are just CH rooted processes. Sure that they are more than that. Containers have a nice developer experience, open source, blah blah blah. Why is CH root the key? CH run. Okay. CH run. Okay, so this was doing this using CH root. Okay, what? Probably doesn't get a mention now that the containers exist, but it's a Unix system call process. This means it's a way to request something from the operating system kernel. Okay, cool. Let's actually learn. This is actually, is it cold in my room? No. So basically, there is a really right now. There's a window right next to my room that I can't fully close. So it's kind of annoying. So it's like I can't fully close it, so I kind of have to sit next to it. But yeah. All right, let's see. CH room. All that means is that it changes the root directory to a new value. That's all CH root does. All right. A file path. Oh, I'm starting to see where this goes. CH run shown should be much more. Could we go? Actually, we go back to the creation when CH root appeared in 1979. Okay, so it's just saying, hey, this is a new directory for the root of the operating system. CH root and CH run. So a user on the Linux system has a current directory. Okay, has a current directory in the root directory, and chroot is a way to change the value. Uroot is the same way cd. All right. Okay, nothing too spectacular here. That's basically the chroot except for this. Okay, whatever. It's just this is just showing me some assembly code. Goes back to okay. So chroot calls the okay, fine, whatever. Call chroot jail. I can set up chroot and change root like this. Okay, so you make a test directory and copy the test directory, and then chroot the test directory as your new root. Okay. Only works as root user. Well, so okay, so now that works. Then you have a Linux. Then after that, you'll go to a Linux user. All right. So then you have some C program or Golang. All right. Making a system call directory. So then you'll execute the hello command, and system call change root, and the output's the same. Interesting. Okay. So there's nothing to process. I can verify that besides going to the shell when you change the root. Okay, so basically it's saying, hey, well, how do we emulate not running the entire damn thing as a root? All right, well, you just compile a Golang program that will actually trigger root change root on it. Okay, fine. Docker run it. Hello. You can only shell into an image with a shell. All right, now we can chroot into this Redis image. But to do that, I first need to get the file system out of the image so I can pass it to. Okay, so Docker save Redis into a image, sure. I'm on the right track, but it's not exactly what I want. Each layer is the union file system that I would need to extract these and combine them in the right order. Okay, so it's basically saying, hey, yeah, all the zipped files just need to be reflected in the file in the folder that I'm creating. It's fine. Okay, so pull, whatever. Okay, so a container is just a process. Interesting. When I run docker run, something happens. An image is turned into a container and started up. It's not really a VM, but if you shell inside and look around it, it seems like one. But now with chroot at hand, you can tell you what a VM means. It's just a process. Oh, now that is interesting. Namespaces mean that you can start a container, you can't see it in your process list, and C groups mean that the process have a CPU and memory limits placed on it. But really, at a conceptual level, it's just a process running a different type file system root. Real containers are just a fancy way to see. Okay, interesting. So then, what's the difference between? I get what it's trying to say, and this is pretty normal. I think if you think about what a VM is and a container, it's really just a set of pre-installed programs and that are copied into a file. And then he's saying that, okay, well, once you do that, once you copy all the dependencies and whatnot, you chroot and name the new folder the root of the entire system. And he's saying, yeah, because Docker are just a process. This is effectively the exact same thing. Okay, fair. Notice about containers that they're ephemeral and relatively isolated. I can run n number of containers from one and they'll be unique. Okay, on exit delete that directory. Alright, sure. Okay, this makes sense. After, so there you go. Who cares? Okay, well, it could just mean by intent that a container is very similar to a process that has just been chrooted, but it's running against the same operating system with a different root. Okay, fine. So containers are great, Okay, here's the interesting part, and I kind of want to make a small comment on this before we hit it, but to my client. But basically, Bazel does almost exactly the same thing because of hermeticity. So let me rewind a little bit. Let's suppose when I talk about Bazel, I'm talking about your build system, right? And some build systems are going to be weird that they're going to require you to pre-install everything onto your OS ahead of time, and that makes making shared building really weird on different machines. You ever get that issue of like, oh, it works on my machine? Well, it could be because I installed Python 2.7 on one machine and 3.0 on the other machine. And so that creates some problems, right? So Bazel has this thing where it says that you have to specify a tool chain, which means that it will download the actual Python version for you. So whether it's 2.7 or 3.0, depending on whatever you specify in your code build, right? And so because of that, what you end up having is, well, you download the binary, you copy paste it, and then because you copy paste it, you will then get access to that because it's in your path. And so when you actually go ahead and do all the dependency downloading and build and whatnot, they get essentially copied into different folder structures, and those folder structures get named as root. That's basically how Bazel works underneath the hood. And what he's saying is that containers are basically exactly just that. So this whole idea of just naming a folder as your path or whatever, or as your main primary directory, is basically a pretty common concept. I think it's more common than people think. So when you really think of like, oh yeah, let me just copy a folder, then make the base of the path of my path variable to be that folder, that's really essentially what everything is. Like all these fancy little like container, or whether it's Bazel or whatnot. I think it's a very powerful technique for dependency management, and I would highly encourage everyone to really remember those small tricks, those tricks and tips, because fundamentally when you go to a system design or when you go to design a program, you can literally just copy the same pattern from an existing program if you understand how it works, and then just kind of work off that. I think it's a really powerful thing just to not have to reinvent the wheel, and then you can point and say, hey, well, Bazel does this, or what's it called? Docker does this already, right? So there's no reason to have to worry like that. There's no reason to have to reinvent the wheel, I think. So I think that's basically what I want to say about that. I think, let me bring on my client. It's pretty close to 11, so let's go. Okay, well, anyway. Yeah, let me quit Discord. I keep getting messages. Okay. Hey, hello?
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 Hey, Edward.
Oh, hey, hold up. Let me turn you up. Oh, there we go. I think you're good. Hello?
Okay, cool. Hello?
Hey, what's up? What's up?
Not much, man. How are you?
Doing good, man. Catch me up on your practice. I know we talked about last time making everything fluid and stuff, but you know that's kind of been your own exploration. How are you feeling after that?
So far, it seems more natural, right? Because I don't have to look to the checklist every time or think about it.
Mm-hmm.
So I did do some problems over the weekend, and it feels like more natural, right? So
Mm-hmm.
I'm definitely gonna practice that some more, right? So yeah, it's been going well. I continued doing chapters on the honor, from the honor section, right?
Mm-hmm.
And there was one that I didn't get the first time, but I waited some time and then I tried it the second time. So yeah, I was
Mm-hmm.
able to get that one.
Okay, got it, got it, got it, got it. Okay. So I'm gonna say that basically you're right. A lot of this is now just gonna be on whether or not you make that jump or not, and really for the most part, the only thing I can do is really just do give you problems and just kind of like point out, hey, you're doing this right, you're doing this wrong. But
Okay,
ultimately, it's gonna be on you to really make that natural. So
okay, okay,
basically our sessions from here on out are gonna be like lighter on the problem solving and more heavily focused on like you trying to find errors in your own thinking or things that are like a little bit too hard, and then just be able to tell me,
okay,
hey, I don't get this. This is like I thought I was doing the right thing here. I don't understand how I can be faster here. That's really what most of our
okay.
sessions are
And
gonna be.
that's during the
Hmm?
Okay, okay, sorry. So that's me while I'm doing the problem, or would that be after we're done with it?
After we're done with the problem, remember what I said is that when you do these problems, you're basically treating this like, hey, yeah, I'm gonna go off my instinct and everything I train. I'm gonna believe that everything I've done so far is right. And then after that, you're gonna
Okay,
go. Then we're gonna talk about, oh yeah, you know, we're gonna talk about, oh yeah, that this is what I think I did right. This is what I did wrong based on the checklists. And then
mm-hmm.
if you find that you're still spinning your wheels after, let's say doing 10, 15 problems, and you keep running into like some issues, or you might be seeing the same types of mistakes over and over again, that's where we're gonna start diving into. But for the most part, I think those your
Okay,
mistakes or whatever are on the stuff that we're gonna talk about is gonna be like is gonna be rarer and rarer, just because like as you
okay,
get better and better at these, there's less and less mistakes to fix.
mm-hmm.
Okay,
Okay, okay.
so with that, let's look at your problem sheet. Is there anything you felt like you could have done better and that you can't quite figure out, or something like that?
Let me see the last. Okay, so yeah, I mean, yeah, I should. Yeah, there was a problem, but I didn't tell algebra, so I don't think that counts, right? So
After what?
yeah, there was one that involved algebra stuff I didn't. So no, let's not talk about that one.
Okay,
Let's do row 188. Compute the maximum of a sliding window.
interesting. Okay, so this one took you 40 minutes to do. All right. Yeah, let's see. This is part of the EPI, right?
Yeah, honors chapter. Yeah.
Okay, let's see. Hmm.
Or actually, I would say it's 35, right? Because I was writing everything down from the book, right?
Okay.
Yeah, let's say 35 for this one.
Okay, let me go ahead and search my book. You said it's chapter 35? What?
Oh, sorry. It actually took me about 35 minutes, right?
Okay. let's see if we can get that down to like 30. But yeah, let's see. What chapter is this one?
This is chapter. It's the honors chapter, chapter 24 in the Python book.
I see. I see a 25 on mine. But
Okay, it's yeah. So if you search for compute the max of a sliding window.
Interesting. I actually don't see that problem in my book. Wow. Compute longest continuous increasing subarray. No.
Let me
Compute
see.
maximum. Oh, compute the maximum. Got it. Found it.
Yeah, I can link you the problem on.
Nope, got it. Okay, I got it. Network traffic is sometimes requires a study of traffic volume over time. This problem explores efficient algorithms for computing the traffic volume. They're given attempts at various stamps. Okay, compute for each input timestamp the maximum traffic over the window length time interval which ends at the timestamp. Okay, compute for each input timestamp the maximum traffic over. Okay, so 25.3. So the maximum traffic over a window of size 3. So this example here says 1.3, 2.5, 3.7. Oh. Well, ain't that interesting. Okay, I actually know how to solve. I know this problem. So I'm actually curious. This should have taken you 30 minutes easily. So let's see what, like at most. 35 is a pushing it, but let's take a look. Use the max heap, where the index would be current L. Interesting. So use a max heap where index would be a current L plus whatever. However, book has an n time solution as a queue with a max value.
Yeah, so that was the missing piece there to get it to n time. So
Yeah.
yes.
So you didn't actually get to the optimal solution at all.
No, the best I thought of this was a heap approach.
Okay.
Yeah.
Well,
And that's what n log L here. So
okay. Yeah. Let's. Do you have the link to the problem sheet?
yes. Let me see that. Okay, send that on soon.
Cool. Okay.
Page 10.
Page 10. All right. Let's wait for the damn thing to load. Okay, cool. All right, let's see what your steps were. Menu solution. So let me see first what did you say your mistakes were. Book that use end by using queue. Look at queue problem with max value in queue chapter. Okay, my question is, when you do this, what is the what do you call it? What is the thing you're going to change in your approach for the next time to get this answer?
Let me see what I wrote down. Yeah, I would say try different data structures, not just think of a
No,
heap, right?
That's wrong. Why is that wrong?
Because I guess that would lead me to more wasted time, right? Like if I throw different data structures, I'm gonna be wasting time and seeing what works better, right?
Well, partially. Remember what we said about shooting randomly and firing from the hip? You only do this when you're out of ideas.
I see.
I remember, I've mentioned this before in the past, I'll repeat it again. That if you're doing this, that means that you're out of logic, you're out of options. And then for you to say, oh, just try more. It's like if you're ramming your head through against a metal like a wall, you think ramming your head harder is gonna work?
Yeah, that
It's
makes
like,
sense.
oh,
Yeah,
if you just like smashed your head harder into this concrete wall, you would have broken through.
hmm
It's exactly the same thing. So again, you're misjudging these. Remember what I told you. We're bulletproofing our approach. So just try harder as a solution or a recommendation is bullshit. So you come up with a bullshit thing. Try again. So we're gonna look at this again, but I never want to hear you say remember every single thing I've said before. I really don't want to repeat it, and I feel like at this point I'm basically repeating myself. So let's see. Input traffic varies window time length. Okay, naive solution each time stands 0. Look back L spaces and calculate max. Yes, that's fine. That's correct. You're constantly looking at repeated entries. Good. Yes. So optimal. So how can we stop? It's technically it's or and yes, correct. So now so you code this up. So how can you get more optimal? Keep track of the max away. Heap that contain. Okay, I see. So as you traverse the heap, insert a heap. Fine. This is good planning. But this gets you n log n. So the next question is, how can we get even more optimal? And I don't see any structure or order to your thinking. It's hard for me to tell what the structure and order to your thinking is.
Mm-hmm.
So, in other words, so I want you to do that exercise then. Think about what this book solution is, and then think about the questions that you need to ask yourself in order to get there.
To get there, I see.
Remember, these are the questions that you need to ask yourself to deterministically get there. So.
Yeah. Okay, so I'm looking at the, it's n squared, right? The naive solution, since you're constantly looking at repeated entries, or n times L, assuming L is a worst case, right? Because say I'm at X, right? You only have to look back L times, right? Or L entries, right?
Okay.
So how can we efficiently find the max, right? How can we efficiently find the max in an array, right?
Mm-hmm.
It's like A, B, C, right?
Mm-hmm.
So that would be my next step in logical thinking, right? It's like, how can you find the max in a set, in an array? Let's just say an array for this example, right?
Okay.
So one way to do it is you can traverse it with, you can do max, right? But this is going to be O of n time.
Okay.
So no, this will be L. Sorry, because you're traversing L elements and you're trying to find the max, right?
Okay.
So yeah. Okay, so yeah, so you're trying to find the max over a set of elements, right?
Okay.
Yeah, so this is something outside of this problem. The logical step here that I was missing, right? Like, because with a queue, you still have elements, right? That you have to process to find the max.
Sure.
So how is that going to be more optimal than doing the max, right?
Okay.
So if
I want you to think about what you really want to say, because is there anything that you said so far that really makes sense?
No.
Really think about. Take as much time as you need, even if it's like 5 minutes in silence.
Mm-hmm. Okay, so at each at each point, I have to look back L elements, right? I can add L elements at any given time to a data structure. As I'm adding these elements, I can keep track of the max element, right? So that way I can get the max element in O of 1 time. And as I'm traversing points in this line plane, I will kick off elements that are less than my current index.
Okay, so you're gonna kick off elements that are less than your current index. So then what's the second, but then how do you get the second, the largest element and promote that then?
How do I get the second highest element?
Yeah. So let's do this. Why don't you give me an example right in your problem sheet? You see where my cursor is?
Okay, let me go.
I'm in your problem log right now. So why don't you give me an example?
Okay.
Walk me through it.
Okay. Oh, I see it now. Okay. Okay. So, for example, let's say it's 2, 5, and 1, right?
Okay.
So as I'm inserting elements here, right? This is my data structure here.
Okay.
I can keep a data structure, and I also can keep a max variable, right?
Okay.
Max equals 2. Okay.
Sure.
So then I'm at 5 now.
Okay.
5 gets inserted. The max gets updated to 5.
Sure.
1 gets inserted. It's not greater than 5, so we just leave it as is. So what this will give me is O of 1 time to get the max variable, right?
Mm-hmm.
Okay. So now let's look at the use case of removing elements, right?
Sure. Yeah. Let's suppose I gave you, I don't know how much. Let's say 9, 8, 7 or something like that. Or actually,
okay.
That's too easy. Let's just say 4, 3, 2.5 or something.
Okay. Okay, so let me continue this example then. So, right, so I would keep adding elements, right? Then I would add a 4, right? It's not greater than 5, so continue, right?
Okay.
At 3, it's not greater than 5. 2.5 is not greater than 5, right? So at any time, right? What is the current max element, right? And that's going to be 5, right? Because I saved it in a variable, right?
Okay, sure. Then what? So let's say we go on to the next one. Then what? What happens?
Okay. So now I'm here, right? Now I have to take into consideration how you would remove elements, right? So, right. So let me copy this down. Right. So crap.
Yeah. So how do you remove the elements then? And what does that get you? Suppose and for the sake of argument, let's suppose my window size is 3.
Okay. So. Okay, yeah, so I would have to do this example again, right? From the start, right?
Let's go ahead.
So,
see what happens.
Okay, yeah. Okay, so window size is 3, max is 5, right?
Mm-hmm.
So let's start over. Okay, so initially max is it's going to be set to negative infinity, right? So we're at 2, right? So we add that to our element. 2 is greater than the current max, so update it to 2, right?
Mm-hmm.
So then I'll add 5, right? 5 is greater than max, right?
Sure.
So update it to 5. Add it here too as well.
Okay.
Add it here, right? Mm-hmm. Add 1. 1 is not greater than 5, so leave it as is, right?
Okay.
Okay. So now we reach a point, right, where our window size is now 4. Mm-hmm. We're going to have to pop off the first element, right?
Mm-hmm.
So remove elements. What 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 does that entail?
Mm-hmm.
If the current element, if the first element is is less than max, right?
Okay.
Leave max as is,
Sure.
and then leave max as is and pop off first element.
Sure.
Else, this is saying element is greater than or equal to max, right?
Okay.
Okay, so then I see, okay, I pop off 2, right?
Okay, so now you
I
have
pop
pop
off
of
2.
Then what?
Okay, I pop 2 since it's less than max, right?
Okay.
I pop off 2 since it's less than max, right? And then I have to take into consideration the new number here.
Mm-hmm.
Okay, so first element is less than max, leave it as is, and pop off the first element. Okay. Otherwise, if the first element, let's just say for the sake of example, right? Let's say it was 10, right? And max was 10 here, right?
Mm-hmm.
What would happen then? Otherwise, if element, so if the element is greater than max, right?
Okay.
Oh, shit. Okay, so if the element is greater than max, what do you do here now?
Okay.
Okay. Okay. So I have the case when it's less than max. Okay. You don't do anything if the element is equal to max.
Okay.
Okay. Yeah, because it doesn't make sense here because you're always gonna have the max element. So how is this gonna help me, right?
Dude,
So
I'm gonna put a pause right now. It's like you should have studied this answer. You should have understood it. You should have been able to go understand the example and be able to walk through this. Why is it so difficult right now for you to just replay exactly what the book said? I want to ask that first.
Yeah, I didn't study the Q chapter for this one.
Of course. No. It's not studying about the Q chapter. It's studying what the book did.
Mm-hmm.
Because from what my perspective, and this is I'm starting to notice this more and more, is that you don't really study the answer to the book, and you just kind of say yeah, and just like next time I'll do better, but then there's no actionable advice from this, and so I'm starting to notice that a big part of the problem of why you can't make that jump is because you're not really honest with yourself about what the real answer is. Like if you were honest, like, hey, I just need to do better and really understand what the book is doing and like why they're getting the answer that they're doing, you would be able to come up with the example for this. But the fact that you're not able to really replicate a simple example or at least relay what the book is saying tells me that you haven't really studied this at all. And so all your practice is going to be absolutely worthless because you don't actually do what I ask you to do, dude. So I'm not going to lie, I'm getting kind of pissed off right now. Like, I mean, multiple times you were basically making the exact same mistake over and over again. Everything has to be actionable. Everything can't just be, oh, I need to try harder. You need to be able to look back at these replays and look back at the problems that you're doing and look at the answer and just say, hey, this is why they're getting the answer that they're doing. And you'll be able to understand it. And if you don't understand it, that's when you come to me. But the fact that you looked at this problem and came up with a blurb for it should have meant you at least understood the answer. And so the fact that you can't even replay the answer back to me, or at least like with their version of the answer, is very, very bad. Like, it's horrendously bad. I don't think you understand how bad it is. It just means that you're wasting your time. And by proxy, you're wasting my time too. Do I make myself clear?
Yeah.
All right. So now that you shrink this window, what happens now?
Okay, so Okay, so now that I shrink the window, right? I'm
And
gonna
how
have
does it
to
get you
pop
close?
off.
And how does it close to get you? More importantly, how does it get you close to the answer? What's the objective? How does it get you close to the objective?
How this gets me closer to the objective is having this a data structure where you have a fixed size of elements, where it will always maintain what the max element is.
Okay.
And I want to retrieve that in O of one time.
Okay. So you're gonna retrieve that O of one time, but then the answer is supposed to be what, an array of elements that tell you the maximum at any window. Yeah. So it's actually, you're returning back an array, right? So the question now is like, how are you generating the array from whatever the hell you're doing?
Okay, so the way I have to generate the array is at each index, you're gonna pop off the max from the data structure we talked about,
Okay.
and you're gonna output that to your results array, and at the end you would return that results array.
Okay. So then why is it that not part of what you're doing?
I got here stuck on trying all the use cases for the queue with the max, right?
Okay,
That's
but
where I
you're
got
trying
stuck.
the use cases, but you haven't even completed the answer. So how do you even know this is even going to be part of the final answer? Again,
Right. So
how do you even know this works? I know we talked about that before.
by testing this.
Okay, but you only tested one part of it. But how do you know the entire answer even remotely works? Have you tried like a simple happy test case?
No.
So you
Yeah.
you might be bulletproofing and testing one part of an answer that doesn't actually work. So at least do a small fucking hypothesis of it looks like it works, then bulletproof test it. I know we talked about this before, man.
Yeah. So what I'm not understanding right now is like, do you want me to test the whole idea, or do you just want me to test this?
I don't even know
idea
what the
that I
whole
have
idea
here?
is. You say you're gonna write it out to an array, but I don't even see you doing that in the example. So you begin to see
Okay.
like, hey, wait a minute, you're only writing like one fucking small part of the answer, but I have no idea where this answer is coming from, and you say, oh, this is how we're doing it. It's like, well then, why aren't you doing it? So show me. So
Okay,
now that you're moved on, you're at 251, right? So then, where is? You said you're writing it out to an answer array, right? So what's your answer array look like right now? Is it like this?
This one.
This is the answer array?
No. What I was doing here, I was testing the queue with a max element, right? So it could return me that in O of one time.
Okay.
Yeah. So yeah. I guess. So here I'm testing how the queue with max variable would work, right?
Okay.
And this is the part when you said, how can we be more optimal, right? Because we're only going back elements, right? And you want to quickly retrieve the max variable in O of one time, right?
Okay. So now you have the max. Now what happens?
Okay. So yeah. So I have the max variable, right? All right. Okay. So we went with this example, right, to test how the max variable would work with the queue, right?
Okay.
So yeah, I didn't complete it here, right? So yeah, let me see. Okay, yeah. So at any point, right? Let's say my window size is 5, right? 3, 4, 5. At any point, you should be able to get the max very rapidly, right? So for this example, it would be 5. 1, 2, 3, okay, all the way up to here, right?
Okay.
So then what if I move over all the way to the end, right? 2 is going to get out of the window, right? And then you're going to add 2.5, right? Your max is still going to be 5. So this is going to give me a quick way to get the max variable, right? With this data structure.
Okay. Okay. But then what happens if your window size is 3, like I gave you? Why are you using max 5 instead of 3? How does this demonstrate anything different?
Okay, yeah, so if the window size is 3...
No, I'm asking why. Why? You changed the variable to 5. My question is why? Everything you do in the problem, everything you do in engineering needs to be specific and have a purpose. Why did you change the variable?
Mm-hmm.
Let me ask that.
Right here, I was testing the example, right? Because when you pop off an element, if it's less than max, you don't do anything, right? I was testing the example of when the variable would be equal to the max, what would we do at this point? So yeah, that's why I put this variable here.
Okay, all right.
Yeah, I think I went on a tangent here, testing this example here.
Yeah, again, I have no fucking idea what you're doing, so I'm honestly just letting you talk this out. Like, you say you understand the answer, and you did, if in order to do a proper diff, between the fucking answer and what you did, you have to first understand their answer. And so you're walking through this, and I'm just like, okay. I'm letting you do what you need to do, dude. But like I said, you're just going and wasting your time and my time. But I'm happy to let you waste your time, you know? Alright, let me see if I can actually understand this, and I'll explain it so that way we're not wasting time here. Okay, assume the input if A is not sorted by timestamp, we sort it. Okay, so that's our brute force is just sorting time, is sorting it. Okay, fine. Intuition for improving the time complexity. Brute force stems from noting that we advance the window only when the boundary changes. Okay, sure. Older elements fall out of the window, a new element is added, therefore a queue is representation of the window. Sure, why not? So you start with a queue, initialized for each, in queue each element, increasing time for each I, iteratively dequeue queue until the difference of the timestamp at queue's head and t is less than or equal to w. What the fuck? Oh, okay, the difference between the queue's timestamp and head is equal to less than or equal to w. Oh, it's just sliding window.
Mm-hmm.
Okay, so then what happens, looks like, is that you are going to enqueue elements, and then while the time difference is greater than w, then you dequeue elements, then maximum volume dot emplace back traffic element of the time, and then the max sliding window dot max that you've seen so far. Okay, so then what happens if you once you dequeue that maximum element? So then they're saying that, hey, while you do that, then they rescan that sliding window each time. Is that really what they're doing here?
No, they maintain a queue with a max variable, right? They point you back to the queue chapter with one of those problems, right?
Oh.
And that's what they do. They'll pop off all the elements that are outside your current X value, right?
Okay.
Anything less than, right? And then they'll add the new element at the end, and they'll add it to the max queue. This is chapter, the honors chapter, chapter 24.
No. The queue with max. What's the derivation of that?
Let me see. It's implement a queue with max API problem 8.9.
Okay, queue with max API. Okay, I see it.
Okay, it looks like they maintain two queues.
So inside of that is a 2Q problem. Wait,
One question I have here is that problem is O event time, right?
yeah?
But also if
Oh,
you do max, that's O event time, right? So and they're using double the space with two queues, so yeah.
interesting. Yeah. NQ max DQ. Okay, so they have a queue that you have two queues, and then so DQ just needs to pop, pop, pop until you find something. All right. So the max queue is like if NQ is not empty, return the NQ dot max, or the maximum of the NQ or the DQ. Okay. So if the NQ is not empty, then you have a queue. Okay, so if it's empty, then you whatever is that. Otherwise, you'll get the NQ dot max and DQ dot max. Okay. But the NQ and DQ are. What the hell is this? Are they both queues? Yeah. Oh no, they're
Yeah.
stacks. Oh, they use stacks. Oh, okay. Yeah, yeah, yeah. So in order to find max dot stack, it has to actually go through each element. It has to actually iterate through every single element and pop them in between the NQ and the DQ. Wait. Has it? Oh, wait. No, it says stack has a maximum of order one amortized. Okay, so it's constant time. Interesting. Why is it constant time? So then you have a stack here. Stack dot max is going to have. Why does stack dot max not? What? Max operations or is returning. Oh, oh, okay. I see. So it returns the top element in the stack. That's what their version of max is, I think. That's really weird.
Yeah.
Oh, I see. Jesus Christ. Jesus Christ. Okay. I understand what. Okay, so then. Alright, so they basically take from this one as well. But it's basically a sliding window, just using something that they actually had created in a previous chapter. Alright. But yeah, no. Then you have to be able to explain this problem.
Okay.
So the way I would have done this if I was looking at the book problem, it's like, okay, it's just a sliding window, except that the queue has a amortized maximum constant complexity. And so the next question is, how do I create a queue with a constant max time complexity? Like you just said sliding window. It's like, okay, yeah, and then with the queue, just be able to put elements in the queue with max, and then DQ whatever element is in there. But if you just do that and then explain this, and then this becomes its own sub problem. That's really it. But you notice here that how I just broke it down. That's the difference between what you did and what I did.
Yeah.
I literally just broke it down into segments. Again, it's just, hey, top level, just do a sliding window, and then with a queue that represents the sliding window amount of the length or whatever that's specified, and make sure that queue can get us the maximum time and constant time complexity. How can the queue get us constant time and constant time complexity? Well, we break that up into sub problem. So
Okay.
that's based. So in order to do the delta between what you did and what it would literally just be being able to come up with that queue constant time. So the only way. So then the question now becomes, if you just keep going down the road, and you're going down the wrong way, then the interviewer will come in and tell you that. But I would imagine that that's probably the only way to do it.
Okay. Yeah, that makes sense. The argument though, this can use a double space, right? Because you have the stack in the queue, right? The stack in the queue, right?
Yeah, you can argue, you can make that argument, but you're going to be using, I would imagine, only 2L of the space, with L being the size of the window that you're keeping track of.
Correct. Okay.
Yeah. So that's really it. I don't really have anything else to tell you other than to you when you do these book
Yeah.
entries, you really have to understand the problem and understand
Okay.
the
Okay.
path that they take to get there, and understand why. And
Okay.
you need to be able to not only that do that, explain it to me.
Mhm.
If you can't even do that, then there's no point in you practicing. There's no point in me giving you problems because you're just gonna go yeah, whatever. I mean, kind of like what you've been doing this session, every single other session. It's like yeah. I mean, I hear it from you, man. So, and if that keeps up, then you're wasting both your time and my time. That's all I'm gonna say about it. So,
Mhm.
what do you want to do, dude? Let me ask that. What are you trying to go for? Do you just
Yeah,
want
man.
to?
I'm gonna do your advice and really understand the chapter, right? Especially these problems that are at this hard chapter. So yeah, that's gonna be my take there, and be more thorough in the
No,
evaluation,
no,
right?
no. See, what I hear is like be more thorough, try harder, etc., etc. Are any of these really that actionable, and are they going to deterministically get you to the answer, or are they going to make you a better
Okay,
programmer?
so I would say for something to be more actionable is truly understand the question in the key, the answer in the key, right?
Yeah. Also,
Um,
why are we?
and
And also,
don't
go ahead.
and don't advance until you don't fully understand it.
Yeah, at least give it a fair shake. Then you said, hey, I understood this. This is what I understand. This is what I don't understand. Edward, help me. That's what I'm here for. I'm not here to like fucking baby you and make sure that you do it. It's like, because keep in mind, like many of the things we talked about, like don't fire from the hip. Don't make sure you break down the problem. Make sure you can explain things clearly, etc., etc. Like all the things we talked about in this session, I know we've talked about before in past sessions. So the real question you should be asking yourself is, why are you making the exact same mistakes? Why is Edward repeating himself? And then the actionable thing would be, okay, well, let me re-examine first my the way I approach things, and make sure that none of the actions that Edward have told me not to do in the past I'm not doing, or if I am doing it, and let me make sure I have a proper reason why, and explain that to Edward, like, oh yeah, I'm trying to do this thing you told me, but it doesn't make sense because X Y Z reasons. That I can accept, and that is actionable.
Okay, okay.
It's like if I go to a fucking basketball game and I ask LeBron, and LeBron James like fucking airballs it, then misses like 3-pointers every like for half the game. I ask him, hey LeBron, like what the fuck's going on, and he's gonna say, oh, let me. I'm just gonna try harder next time. What, you weren't like trying harder already?
Yeah.
I'll be more careful next
Yeah.
time. Like, no. I think that's fucking bullshit. If LeBron comes to you with that excuse, are you gonna
No,
fucking
that makes
support the
sense.
Lakers?
Yeah. No.
I mean, maybe it's like
Not
some
anymore.
political answer that people will like, but like to me, if I'm thinking, hey, I want to put money on this team, I'm betting on it, if I'm gambling. By the way, I'm not gambling, by the way, for everyone. It's like I really want to know what actionable things he's gonna do. Maybe he'll like watch the tape, look at exactly where his foot placing was. Maybe look at his finger, to how they release the ball. Maybe he needs to actually shoot more hoops at that exact point. Maybe his weak point is shooting from the side of the rim, not from the front, etc., etc. You see, like how that's more actionable, right?
Yeah, correct.
It's the exact same thing here. Like, what's more actionable? Why are you getting these wrong? Why are we repeating ourselves, etc., etc. So honestly, I'm in a pretty bad mood right now. I don't feel like doing a problem today.
All right, man. Well, yeah. I'm gonna do this problem again and fully understand the key. So
Yeah,
I'm
and
gonna
next time,
do that for the rest.
yeah, we're gonna have a real fucking problem if I next time point to a problem and say, hey, explain this problem to me, and you can't do it simply. We're gonna have a real fucking problem, dude.
Yeah.
All right, I'm gonna let you go.
Okay.
All right, later.
See ya.
All right, I'm gonna shut off the stream, dude. I'm pretty fucking pissed off right now. Like, it's like we're repeating mistakes and shit and talking points that we talked about before, and it's like, if you're like, what's the point of doing the delta between the book and what you're doing if you can't understand what the fuck the answer is? I don't get it. Like, it doesn't make sense to me. I know I've talked about it before in the past, and I'm just like, what the fuck is going on? So I mean, is it whatever he wants, dude? He's gotta be more honest with himself. That's all I can fucking say, man. It's like I'm staying up, and I'm spending my whatever time I could be out there in New York drinking, whatever. I'm here, and I'm wasting my goddamn fucking time, man. All right, whatever. I'm gonna shut out the stream, guys. Thanks, guys. Well, fucking, yeah. We'll be back here Thursday. That's all I gotta say. Later.